Welcome, everyone. We're going to wait a few seconds. Just to make sure that everybody can get into the meeting. As a reminder, if you've joined us already, make sure that your first and last name are listed in the participant list so that we can accurately report your continuing education credits for you. If you have just a first name, please make sure you add your last. That will make my job a little bit easier. And we've got a few more people trickling in here. But in the interest of time, probably want to get started. So with that, I am going to introduce Sam Roberts with the Garland Group. Garland is a sponsor of today's session, Dark Skies, More Than Just Romance, Light Pollution, Urban, Environmental, and Design Issues. And with that, I will turn it over to you.
Thank you very much, Kira. Appreciate the opportunity to sponsor the event tonight, and also appreciate being involved in Build Pittsburgh this year. So for those of you who are not familiar with the Garland Company, we are a 126-year-old manufacturer of roofing and waterproofing materials. We primarily focus on roof membranes, standing seam metal, and rain screen type systems. And our model also allows us to provide quite a bit of services and support to design professionals such as yourselves. Services include anything from initial condition assessments to guide specifications, detailing, wind uplift calculations, that sort of thing. So our focus mostly in the Pittsburgh area in particular is on long-term durable systems. And that's anything from the roofs to walls, and mostly with institutional type clients. Primarily we work with schools, hospitals, and other municipalities who are really focused on receiving long-term, durable, low life cycle cost roof and wall systems. So I'll wrap it up pretty quick. If anybody would be interested in reaching out to set up a meeting where we could further introduce ourselves, whether that's in person or virtually, please feel free to look me up on LinkedIn. Again, Sam Roberts with the Garland Company. You should be able to find me. I'd be happy to stop by your office or set up a call just to understand how we can better support your firms. And also just wanted to remind everybody to mark their calendars. Coming up on June 24th, we are going to be providing another AIA accredited presentation to all of AIA Pittsburgh. So this presentation will be on designing roof systems to meet sustainability goals. So it should be a pretty interesting presentation, and I'm hoping many of you guys are able to participate. So with that, Kira, thank you very much again for having me. I hope everybody enjoys the rest of the presentation. Has a wonderful evening. Thank you very much.
Thank you. You're up, Stephen.
Okay, thank you, Kira. Hi, I'm Steve Quick, both with Carnegie Mellon University and also my own consulting firm, Civic Design and Planning. And I'm here with Grant Irvin. Grant, you want to say hello?
Hello, everyone. Great to be here. And Steve, great to join you.
Okay. We're going to talk about light pollution, both from the sort of research side of it, as well as what we've learned about it in terms of not only street lighting, but also lighting in general. And then we're going to finish up with Grant at the last to tell us what's in store for the city's initiatives in both of these two areas. So I'm going to get started, if I can. Light has always been, it's over the last almost 150 years now, we really celebrate it. And this little video here really makes that point. for the satellite design some places, the light begin with solitary stars at night. Other places, yes. The satellite even distinguished satellite passes over darkness within it. Shows how human settings political boards are sparkling behind fishing boats that not in yellow sea. Not all bright selected. Glowing just as bright, flaming wildfire burn. This new view impact of human population, how faint or how bright their might be. This is a map taken by one of the VIIRS satellites and showing light pollution. This is stratified by the amount of light pollution. So the white that you see is the brightest, and then it goes down to green, to blue, and then finally to black. But you can see how the whole eastern seaboard of our country and just the far west coast, how we have lit ourselves pretty rapidly. When we look at Pittsburgh, taken from the same International Space Station, this is Pittsburgh. And you can see our downtown area right in the center at the Golden Triangle, and also on the north side as really being the center of what you saw as we look at it here from the VIIRS mapping. These maps, incidentally, are available to everybody, and they update them on a yearly basis. They started around 2009, 2010 with fairly low resolution, and this is actually a low resolution satellite imagery. And they've gotten much better now. So we're able to get a little bit closer readings on where we are getting the light. But still, the problem we've had with it is this is the best we can do in beginning to map light pollution. There's another type of light pollution, not only looking down, which we do with satellites, but also looking up. And we call this sky glow. And this is Los Angeles. And you can begin to see that the amount of light that is reflected or shown up into the sky actually covers and forms a dome over our cities. And we see these over all of our urban cities. And Flagstaff, Arizona is actually one of the best in terms of really regulating sky glow and this sort of dome effect. But you can see once that light gets up into the atmosphere, you can be on the other side of a mountain and see the glow from the city on the other side. So this is not helpful for anybody who wants to see the Milky Way. And what we've been finding as we've been looking into this, very few people have been able to really see the Milky Way. Most people who are grow up in urban centers never do see it. And it's not until you get outside of the city and you actually get into really dark, what we call dark sites, of which there's only a few in the United States, can you actually see all of the thousands of skies in the Milky Way. So this is the Bortle scale. It's a way of how you can measure light pollution just by sort of trying to guess how many stars you can see at night. Most inner city situations, and this is Pittsburgh, we're in the number 9, which is the worst case category of all of them. And it's not until you get outside of the city, until you get to a suburban sky or a 5 or a 3 on the Bortle scale, and very few people actually get really to a number 1. What is light pollution? It's been defined by the International Dark Sky Association as artificial light at night that is excessive, obtrusive, with adverse effects. And it's caused by basically four things. First is glare, which we'll show you some examples of that. That's excessive brightness that can cause visual discomfort. The other is urban sky glow. That's the brightness of the night sky over inhabited areas. The other is light trespass. And this is where we as architects and designers, it really becomes an issue for us because just about everything that you light, even from the inside, gets to the outside and can be reflected back up into the atmosphere. And the last type is clutter. I guess the best example of that is Times Square, where you have so many competing types of light that it's really hard and it's confusing. And it's really hard to understand your orientation and so on. The problem with it is it's growing at 2% at a minimum annually. We've been noticing recently it's actually growing in some places 6% and above. And why is this important? There are several effects of it, and this is really one why we wanted to give this talk, is that not all lighting and not all LED lighting is perfect. And once you begin to understand the qualities of the light and what they can do and they cannot do, and what types of perhaps harm they might occur or cause, it's important for you to know that as a designer. They have quite an effect on the natural ecosystems. Just about all living things. This includes animals, flora, and ourselves as animals as well. It does interfere with us. Human health. What we found is that LEDs with typical LEDs with high blue light wavelengths in them have caused serious healthcare issues across the spectrum. And it can be from sleep disorders to cancer. The medical profession is now starting in the last 5 or 6 years to start documenting this. The other thing is economy. We waste in this country $6 billion a year by overlighting. A lot of that is just normal lighting, which we do with street lights and so on, but there's a good share of that is actually wasted light, putting light where it's not needed, and so on. We're also seeing global climate disruption. Our carbon footprint, specifically because we are producing more energy to light our cities and so on, we are also in the process of increasing our carbon footprint. And then there's the ethics issue. And this is becoming more important, I guess, as people begin to learn what they're really missing. And that's the enjoyment of being able to see the night sky. And those of you who have witnessed the Milky Way, either up in the high mountains or really in desert areas and so on, you cannot, there's no way to tell you or to even describe that to anybody, what a fantastic phenomenon that is. And you really begin to see yourself as part of a larger ecosystem. It has the same kind of effect as that photograph of the Earth taken from one of the moon missions, where we see how really small we are and how important it is that we begin to think together and work together, particularly for things such as these polluting issues. Where we see it with wildlife in particular is with bright lighting, we create predator traps. So any light, as you've seen the moths gather around at night, well, you can imagine light out in the wildlife areas and particularly outside of cities. Insects gather at those. They are natural breeding, or let's say killing zones for predators. And we've seen a tremendous decrease in insect life, and we're seeing it as well as in other types of living creatures. But it affects fireflies. We don't see as many as we used to. It's affecting all types. I know just in my backyard over the last 10 years, we probably have about a quarter of the fireflies we used to have. So it is affecting the population. Time magazine just a few years, just last year, estimated that 9% per decade is what we're losing in terms of our insect populations. It's even gotten to be such that the LED folks, those who put out professional journals and so on, are beginning to take into account that it is an issue. And so we're beginning to see that manufacturers are beginning to take this seriously. And you can see in the last couple of years, the amount and the different types of LED lights you can now buy at Home Depot or Lowe's or those other places. There's quite a range. There didn't used to be. There used to be only one type, and those were really quite terrible. But the industry is taking effect and beginning to notice this because I think the responsibility, such as we see with manufacturers taking with the LEED program and so on, these things are becoming important to consumers. And we as designers are in that sense of consumers in the sense of specifying these things. But let's talk about how it affects us. We're all familiar with the circadian rhythm phenomenon. And what we begin to see, and when we map that out, is what it does in terms of the melatonin and cortisol production in our bodies, such that we produce melatonin when we're asleep, we produce cortisol when we're awake, and these become the ways that really we think about all of human history and so on. These things have developed because of not having light. And so therefore our bodies are used to a pattern of which we sleep at night and we produce melatonin, and when we're awake, the cortisol is affecting us so that we can be awake when we need to be awake and asleep when we should be asleep. However, with certain light, and particularly LED light that is not really thought of carefully, as I mentioned, the amount of blue light that LEDs put off begin to really affect how we react to the circadian rhythm. And it affects our hormonal system and also our nervous system. And you can begin to see here, we take this in through our eyes. It's transferred though to our pineal gland, our pituitary gland, brain stems, and so on, and it begins to throw our internal clock system off. And as we begin to look at what happens when you start to get off of that pattern, it's going from the one at the top to the one at the bottom, you can begin to see as you start to, let's say, be more affected by light at night, particularly if you work on your computer, till late in the evening, you begin to throw off that whole system of the melatonin and cortisol. Those who work 3 hour, the late hour shift and so on, they're down at the bottom, where their body is just reacting entirely different than the natural way of thinking about it. So shift times and so on, and working the third shift is really disruptive, not only to circadian rhythm, but it also affects health. Going back just a little bit to talk about how the eye works, I think is important simply because what we can see and what we can't see begins to give us a little bit of hint into why light is important and what type of light is important to us. We've all known about rods and cones. Cones are what we see our color with during the daytime, and our rods we know that affect us during the nighttime. We see color with the cones, and with the rods, we see only gray tones. But what we found just as recently as 1998 are things called ganglion cells, which I'm going to go back here for a second. They're the things on the left-hand side of the retina in the diagram on the right. These were not discovered until only maybe 30 years ago. But they found that these are the things that really are important, because these are what take into effect and transition us between daytime and nighttime, our ability to see. And that period of which we're transitioning between photopic, which is our cones, to our scotopic, which is the rods, we're seeing what's called in the mesopic vision realm. We in urban settings never do get to scotopic. we are always in some type of ambient lighting condition, whether it's artificial light or it's moonlight or even starlight. So we're kind of verging always in between these two. And it's not until you really live out in a very rural area will you even begin to even approach scotopic vision, but most people now are not reaching that. What this does is, again, this affects our circadian rhythm. When we look at how we adapt to light, human eyes, we adapt for healthy and younger people after about 20 minutes. And we can see here the scale on the top with ambient light levels from sunlight on the right-hand side down to starlight on the left, and then how our pupils dilate or depending on the amount of light, how they close down or they open up as the nighttime changes. But as we age, our eyes react differently. And we'll get into some of that a little bit later, but it's amazing the difference between somebody who's 20 to 25 years old versus those of us who are over 60. The reaction time becomes really interesting and also an issue, particularly for our street light. When we begin to look at what we actually see in all of the electromagnetic spectrum that's out there, what we actually see in the visual range is that in the very middle. It's called the visible light spectrum. And you can see how on the Kelvin scale, which is a Kelvin scale is when you take a piece of iron and you heat it, it will change color the hotter it gets. And so when we talk about something that's in 2200 degrees Kelvin, it's actually quite cool. Once we get what we call red hot or white hot is when we begin to get the very bright whites, and actually sunlight is a very high Kelvin temperature. So we've developed these ways of beginning to think about the light spectrum and how we begin to think about how our lighting and how our lights work themselves. The violet and the blue range, which are shorter wavelengths of light, these are the ones that are the problem ones. Once we get into the greens and yellows and oranges and reds, these are longer wavelengths, and we do well with those, and they keep us within the rhythm. But when we look at comparison of sunlight to incandescent light to white LED lights, you can see the real difference here. On sunlight, we're up with a fairly equal spectrum across the, even though it's peaking in the greens, we are still seeing a fairly even spectrum across the full wavelength. Our incandescent lights, which we're all used to, and this is the one that we use as the baseline indicator of high quality light, because it's what we're used to and what's everybody in preference studies as preferred. It actually peaks in the yellows, oranges, and reds in terms of its type of coloration. We call that warm light. When we get into the cool light ones, which are the blues and the violets, we begin to see that those really are getting more into natural sunlight. But the LED lights, those which are not covered with phosphors now, where we can change the color temperature, they will spike naturally in the blue spectrum. And that's where the medical profession and the circadian rhythm issues are really occurring. This is an actual graph of a typical LED light. And when we begin to think about this, and we look at it in relationship to the sun and the moon, we are actually getting more blue light out of LEDs than we're getting with sunlight during the daytime. And that this peak wavelength on the left-hand side is really where where that blue light is affecting us. But between the sun and the moon, we're actually we have more impact in terms of intensity of light with LEDs. So one of the issues that we have is how do we make choices about lighting between energy savings, the visual quality, color rendition, and so on. And this graph here shows sunlight on the top left and incandescent lighting on the top right. And the other types of lighting that we generally work with are those on the bottom. On the left-hand side, fluorescent light, high pressure sodium, and then monochromatic LEDs on the bottom. On the right-hand side, there's high pressure mercury, which we don't use anymore, metal halide lights, and white LED lights. We need blue light to see, though, to make clarity, and we'll get to that in a little bit later. So we still need blue light, but we have to be really careful about how much blue light we actually let through. So here we have high pressure sodium lights, which we're all used to in the city of Pittsburgh, although we've been relamping a number of the commercial areas and some major arterials with new LED lights. And they're basically the same color you see here in the center of this photograph. This is used for advertising by the lighting industry as being, this is what we should be doing. However, what we are doing is actually could be creating something that may be even more troublesome. And that's what reason why we wanted to make this presentation today. The more we try to simulate daylight, the more we create problems. Our natural circadian rhythm is such that we need to shut down at nighttime and not have the blue light and the other types of light that would keep us awake, such as looking at computer screens or anything else that's producing high blue light. Blue light gives us a lot of clarity, but yet it really messes with our systems. And so trying to emulate daylight, which is very high in blue light, by the way, even though it's full spectrum, and we really spike the blue light with the LEDs, we could create potentially more problems than we are really solving with all the energy savings behind LEDs. When we look at design, the types of lighting we want to do are those which are in this 45-degree cone, where we're lighting just what we really need to light. And this is ideal. We do this indoors with 45-degree cutoffs with our fluorescent lighting and our incandescent or even LED lighting. We're very careful about that, but we don't apply the same principles outdoors. We not only light beyond the 45 degrees, but we also light brighter than we really need to be able to see. So light trespass is everything that's outside of the yellow triangle on the left. And any light that is more intense than is actually needed is bounced back up into the sky. It's called upward reflected light. That's what causes sky glow. So even though our streetlights may have 45-degree cones, if they're lit too bright, that just any of the extra light is bouncing up into the sky. We're also getting light spill from buildings. And so any building that in a sense is lit up at night, and you know how we celebrate lights here in Pittsburgh with Light Up Night and so on, it's all sending the wrong message about light pollution. We should have dark sky nights, and we've tried that a few times, and we may be bringing that back, but where we turn off all the lights downtown so you can see the stars. But we as designers need to think about how we specify lighting, and particularly lighting with LEDs, which we can control, that we can turn off lights at night or turn them way down so we're not contributing to nighttime pollution. Glare, one of the polluting types, is not only, as we see in this patio lighting here, but it's also an issue with our street lighting. And as you begin to shield that glare, we can begin to see a lot better. When we've done studies with glare and we talked to the public safety officials here in Pittsburgh, they would rather not have lights at night because when they get the street light glare in their eyes, they cannot see between buildings. And so they would prefer actually that we either lit very much lower than we do, so we don't have the high contrast situation, or we begin to think about shielding all of our lights and turning down the intensities. So this is what a typical glare situation looks like on most streets. And we get this not only with high pressure sodium, but we're also getting this with LED lights. And when we, in rain and so on like that, where our street surfaces are very highly reflective, all of that light is getting bounced back up into the sky. So the way we design streetlights and such, we don't put them right next to one another. We generally space them further apart. And once you get out of that 45-degree zone, we begin to get into the glare zone. So if you're looking at a light source driving or walking and get beyond that 45-degree cone, you are seeing the light source itself. And one of the issues for those over 55 years, and here this graph here with age versus the recovery time, it's for someone who's younger to someone who's over 55, there's anywhere from a 25% to a 200% slower reaction time for your eyes to adjust to the situation. So for somebody who's 65 or older in particular, when your eyesight's not as good anyway, you are going blind when you're faced with glare conditions, and it's really dangerous. So we have to take these two things into account as well. As we've been lighting cities, down here on the bottom is Los Angeles before and after. There are high pressure sodium lights on the left and new LEDs on the right-hand side. You can see the difference in brightness. All that brightness is going back up into the sky. Where we have the most trouble, frankly, in controlling are the decorative fixtures that are so loved by people who are in the commercial business and so on, and sort of those in high, let's say in historic areas and so on, to go back to the teardrops or the acorn fixtures or the globe fixtures and put LED lighting in them. We couldn't be asking for anything worse, simply because LEDs work differently than filament lights. With LEDs, the light source is a diode, which is very directional. And so it works like a spotlight, and it sends out a light beam, very directional. And the reason why you see the lighting arrays on so many streetlights is they can put those diodes in the locations where they're going to throw the light, where they can get the broadest kind of cone or spread. And so therefore they're having some facing down and some are beginning to phase outward because of the directionality of them. Those that face outward get above that 45-degree cone, and they shine directly into your eye. But it's not only that in terms of shielding, but also we can see the brightness, and it's the brightness which causes the reflectivity issue, where we're getting more lux, or what's called illuminance, up back into the sky as sky glow in the process. We do need contrast, and all of us who know we don't see form without shade or shadow, and so that's absolutely necessary. So what we need to, when we think about lighting, we don't need light to be really bright, and we don't need really high contrast. We just need enough so that we can make out shapes and forms at night, and particularly in the driving times when most people are out, and that's before 11 p.m. at night. From dusk to 11 p.m., for example, nighttime, and it's dusk where we really have that change of what we're seeing, and our reaction time is getting worse in the process. So we do need contrast, we do need shadow, but we don't need bright lights, and I'll show you an example of that. But we also need color, because we're not getting to the full gray spectrum that our rods are capable of seeing. We still need color. And so therefore, as we begin to think about it, how can we bring color more prominent, the ability to see color at nighttime more prominent so that we can see better and begin to pick out objects in the roadway. There's a lot of experimentation going on with LiDAR and radar and other things to pick up objects with autonomous vehicles and so on. But those of us who still drive, we need to see color to be able to pick out things. We're good at picking out reds and blues, but we're not good at picking out other colors. So what we really want to be able to do is, like the photo on the bottom right, is be able to see those objects which we really need to see at nighttime. And how do we light for those conditions? There's a lot of thought, and the IES, the Illuminating Engineering Society, who writes most of the code and the guidelines for street lighting, they mistakenly, and I think they're beginning to see the problem, when they're on the high-speed limited access freeways and so on, they believe that you really want to create as much of a daylight condition as possible in order to be able to see. As you can see, when you get this kind of brightness, it may be fine for somebody who's younger, but those who are older have a really hard time seeing in this. And you cannot see anything to the sides as well, because you're so focused on the light that's on the roadway surface itself, that everything else appears black on both sides and also in front of you. What we found is the best type of lighting for people to be able to see well is what we call non-uniform lighting, where we're lighting with sort of overlapping ovals where we have light, dark patterns. So we're not bright like on the left-hand side, but beginning to really tone down the light intensity, we can actually see better. Experiments we've run on the Carnegie Mellon campus where we've tested streetlights, and we tested them at different intensity levels and so on. We were getting more clarity, not only by just our own observations, but even when we were taking photographs of those, we were getting better clarity with photographs with lower light conditions. Color, as I mentioned before, daylight is up around the 5,000 Kelvin on the left-hand side, and it's also associated with the left-hand side photograph for that building. We have to be very careful about color. And once we go above 3,000 degree Kelvin, we begin to get into spiking the blue light. So we can stay neutral below 3,000. We are recommending that we really light the city with 2,700 degree Kelvin LEDs, maybe 3,000 when we need to at certain intersections where we do want a little bit more blue light just so we can see a little bit clearer. But generally 2,700 degrees is what we are really trying to hit. And that's what we see on the right-hand side. The 4,000 is 3,500 to 4,000 is what we see in the middle on this. The other issue is the color rendition of the light itself. Most LEDs are in what we call the CRI. It's a color correction index. And it's because LED lighting is not filament lighting, but it's electronic lighting. They've gone to an equivalent scale called CRI. And so that's as close as we can get to actually emulating the light that's with incandescent and filament type lighting, but the scale is almost the same. LED lights, standard LED lights are in the 70 to 80 range. As you can see, we really need to get up to as high a CRI value as we can. Incandescent lighting is 100. And you can see the difference down in the photographs on the bottom as we begin to correct for coloration with lights. We're getting, we can see a lot better as well. The best we've been able to do with LED lights, there was one company, but they're now out of business. They were able to get up to around an 80, 85 CRI, but they could only do that with about a 2,200 degree Kelvin light, which is very much like high pressure sodium in terms of its coloration. We have a long ways to go before we get really true color. And the reason, again, coming back, we need to see color at dusk times and at night because it's dangerous without being able to see color. The other issue with visual acuity, which is a trade-off between color temperature and blue light and all of that, is really how we do see clarity. And on the left are the two visual tests, as well as whether you're colorblind and so on. But the real factor is here, we need a certain amount of blue light to be able to see color clearly. And so there's a trade-off, and the manufacturers know this, as to whether you begin to think about how do you color correct, how do you also have enough blue light to be able to see, and at the same time, how do you manage the intensity of lighting such that you get the right kind of balance. And as development begins to become more, let's say, better in terms of research and so on, we're going to be able to bring this visual acuity and the color correction up to higher. Astronomers like the high pressure sodium, the 2200 degree Kelvin light that we have here in Pittsburgh, because they can filter out that light and see right through it. They can't filter out blue light, and they can't filter out full spectrum light. And so therefore, there's a lot of observatories that have closed up until you get into just a few places left on the planet where you can get through that condition and so on. And so there's a little bit of tug of war going on now between those who are with the International Dark Sky Lighting, because they just lowered their recommended color temperature down to 2200 K from 2700 K. Those who photograph at night, those who need to see color at night, are a little bit skeptical of that, myself being that same. I'm really cautious about going into the really warm yellow lights at nighttime. I think we need the ability to see color. What we've had just recently is both the International Dark Sky Association and the Illuminating Engineering Society have joined in a partnership and beginning to now really look at the quality of outdoor lighting. Why this is important are for several reasons. When we first started looking at LED outdoor lighting for Pittsburgh back in 2010, when we started the studies on that, you could only get the really white light types of LEDs. And there was very little research that was done at the time, but that's what we had. And that's the LEDs that you see that are up in Pittsburgh right now in all the streetlights. They are the ones with the basically a temperature of around 4,000 to 4,500 degrees Kelvin rather than the lower Kelvin temperatures. The other factor to keep in mind is that cities purchase lights based upon cost. And when you're like Pittsburgh, needing to lamp over 40,000 streetlights, that cost could really get pretty high, particularly when you're talking around $200 a light fixture plus $100 to install it. That gets to be pretty expensive. Since the public was not aware of the problems with LED lighting and the issues of light pollution, the manufacturers were fine with putting out those, which were cheap to produce, the non-color corrected types. They could produce them very, very inexpensively. Cities liked them because the amount of energy savings and the cost and maintenance were a fraction of what it was costing them for the high pressure sodium lights. For example, a sodium light bulb would last 2.5 years. An LED array will last 10 years. So 4 lamp changes within that period of time, each lamp change costing the same as a light fixture costs, roughly around $200. Maintenance costs as well, because now you had light which was guaranteed for 10 years with LEDs instead of just the 2.5 years. You were saving money on maintenance costs, plus the energy savings from LED versus the filament type of lighting. That's why cities are going so fast to change over to LED lighting, just because of its efficiency. And the manufacturers were producing them as fast as they could because it was a low cost bid, which takes the prize. But the manufacturers are now realizing that they need to be more responsible. So we've started to see them now beginning to put research and development time into outdoor lighting, whereas all of it was going for indoor lighting, which is where all the real changes have been occurring. Outdoor lighting was always the poor stepchild that didn't get the shoes. Now we're seeing a bigger change in that. And with this partnering with the IES and Dark Sky, I think it's in the right direction. What we have been doing in terms of research has been using drones, and we're looking for other means to photograph the city. And we've been testing streetlights on the campus. This was just taken a year and a half ago, before the pandemic. This is the campus. Phipps Conservancy is down in the bottom left. And you can see that the Carnegie Mellon campus is quite a light polluter. Just not only with the LED streetlights, which you can see in the bright white on the streets, but also with lighting the campus, particularly Eastland Stadium and the tennis courts and even the Hunt Library. And the cry and the wish for most of the students on campus is to increase the brightness so they can see at night just as well as they can see at daytime. But we're contributing on campus to the problem. What we've been doing is beginning to measure, and what we want to do is map the city of Pittsburgh both before, during, and after a streetlight conversion, so we can measure what the impact is going to be. And we can do this and correlate this, and the idea is begin to computer read what our lights are telling us, and where we are not only seeing too much light, but where we're also not seeing enough. And so it's an equity issue as well going on that. But our intention is to try to map this and begin to use computer read photographs to be able to give us an index or measurements of the city. Our intention with this kind of research is to come up with a low-cost way that every city in the country and around the world can measure their light conditions with the relamping to LEDs, and begin to really take that light pollution map that we're getting from the satellites and take them way down, get that light pollution as best as under control as we can. So not only with photographs, but also we're measuring sky glow. On the left, we can do this with iPhones. There is a sky quality meter setting that you can get for free, of which you can hold your iPhone out over the top of your car and get a reading. And this automatically goes to an organization that's worldwide called Globes at Night, and they will map that, and they're beginning to, as a citizen-led type of way of beginning to make awareness of light pollution and so on. So we've started doing this in Pittsburgh. We did buy the ones on the right-hand side, test photometers, which we bought 12 of them, and we want to put those up around the city. They will continuously measure sky glow on a daily basis. And so you can see why not only street lighting, but also with dark sky conditions and so on, we have another polluter out there that most people are not aware of. And so we've been spending most of our time lately as much educating people about the need to be careful about the use of LEDs and understand what is important and what you have to watch out for when you do specify LEDs. We've been working with the city on the streetlights and so on. And lately we've been working with Grant and his team on a dark sky type of legislation. I'm going to let Grant take it from here.
Great. Thank you, Steve, and thanks everyone. Maybe Steve, if you want to advance to the next
Hello, Grant?
slide. Yeah, if you want to advance to the next slide, please.
Grant, I'm not.
Yeah, just to give you a little bit of insights in terms of the city's commitment and our approach to these issues. So we've focused in on dark skies over the last couple of years and working with Steve and Diane Turnchek at Carnegie Mellon in terms of investigating the impacts of dark sky lighting and how we can incorporate it into the work that we are doing. From our perspective, one of the biggest issues or ways in which we've been able to fold this into our work has been through the city's climate action plan and understanding the role that lighting has on energy performance. And Steve has talked about kind of the impact that LEDs have, but it goes beyond just the opportunities with regards to energy efficiency. There's a host of other confluencing areas that we've leveraged through our commitment to the United Nations Sustainable Development Goals that have allowed us to take a holistic approach to sustainability and climate action, but also think about issues around education and health and affordable and clean energy and how they all intersect into these some of these issues in a common format. LED lighting and light replacement being a critical one among those. Next slide, please. And so we've been on a trajectory of working on issues related to climate, dating back to 2008 from the initial Climate Action Plan and through the development of Climate Action Plan 3.0 in 2018, but also into kind of deeper integration work of climate and energy now into the Department of City Planning, where I serve as the assistant director. And so taking on issues of code and kind of the normal course of business, if you will, in terms of building and energy decision making that happens every day through kind of the typical development process. A key focus of ours has been to try to find ways in which to intersect the areas of climate change and a just equitable transition, and making that at the forefront of the built decisions that we make in the built natural environment. So for example, last year, one of the key pieces of legislation we passed was for the city's facilities a net zero energy code. So effectively making all new construction and major renovation that the city undertakes to basically have a net zero energy standard. And so we see street lighting as being one of the next phases of holding ourselves accountable and making a big positive contribution with regards to climate action through the exchange of streetlights to LEDs, but also doing so with a dark skies standard. Next slide. So just to give a little bit of insights, these are the city's climate action goals, one to really focus on why LEDs are so important and why energy efficiency is so important to emissions reduction is that LEDs just for the city's operation, or excuse me, streetlights, just for the city's operations make up about 40% of our electrical bill. So when we're thinking about cost containment and cost efficiency, that's a leading way for us to hit our 50% energy reduce consumption targets, and then also find ways in which to align that with our emissions reductions goals. But it's also important to think about this from the standpoint of ecosystems restoration. So like Steve had mentioned early on in his presentation, the impact of lighting and that it has on the environment in terms of both our circadian rhythms, but also in terms of habitat for wildlife, including people, and how that factors into some of our decision making. Public lighting is a major opportunity area for us to make those a positive contribution. Next slide, please. This slide just shows you some of our pathways with regards to that 50% emissions and energy consumption reduction. So one of those key strategies has been identified by the public as being modernizing our energy and infrastructure. And so LEDs and streetlights fit a key component to that. Next slide. As I had said, one of the things that we are working on, pretty intensely within this Department of City Planning is integrating energy and energy planning more into the work of the Department of City Planning. So both through mapping and scenario analysis as part of the city's first comprehensive plan that is currently underway, as well as thinking about how our intersections with district energy systems and the electrical grid provide major opportunities for emissions reduction and energy systems modernization. Next slide. And so one of the ways that we are doing that is through leading by example. So effectively, just to focus in on one here, is really about creating standards like modernizing our lighting code. And so thinking about how we can integrate the International Dark Skies Standards into our lighting code is one of the key aspects that we're working to integrate that policy into city operations. And also alongside of that, working to also engage and educate communities about the importance of both dark skies lighting as well as LEDs and the benefits that go alongside of them. So over the course of the next few months, we'll be looking to have some focus group and engage conversations with community leaders and organizations like AIA about how we can better shape the policies with regards to lighting. Next slide. Some of those things, many folks are familiar with all these, but ways in which we have kind of benchmarked our performance have been through the 2030 District Challenge. Quick commercial, I guess, for another event tomorrow with Green Building Alliance's 2030 District announcement. So another close partner with us, like AIA, in terms of advancing sustainable energy solutions for buildings. Next slide, Steve. And so just to dive in a little bit about kind of the Dark Skies Initiative for the city of Pittsburgh, we've been working with a team both internally as well as the Carnegie Mellon folks and IDEA to help develop a Dark Skies code revision for the city's lighting code. And we're working on this and hoping to introduce it over the next couple weeks in preparation for a street lighting replacement RFP that will basically go live probably next week, maybe the week after. And so we're trying to sync up effectively the modernization of a dark skies code in preparation for a street light replacement that will begin in early 2022. Next slide.
I think that's it, Grant.
That's the punchline. So there you go.
I think that one lesson that we've learned by working on this for a little over 10 years is the importance of controls. That whenever you're putting in any LED lighting, please always have controls. The only thing you need to do is to be able to turn them on and off and be able to dim them. And by being able to do that with timing, we can do a tremendous amount of light savings, light pollution savings, as well as get better lighting in the long run.
I think we have about a minute left. If there are maybe some room for one or two questions, please feel free to unmute yourselves or use the chat. Okay, so you guys answered all of their questions. They have none.
It's been a long day.
Well, thank you, Stephen. Thank you, Grant, so much for joining us this evening and speaking with us about the light. And Garland Company, Sam Roberts, for sponsoring today's session. Thank you, everybody, for joining us, and we will talk to you soon.
Great. Thanks, everyone.
Okay.
Thanks,
Good
Steve.
night.